charity.
Cosine. These are.
This is different from last week, right? We'll show something new.
I don't know. I gotta look and see how many things we have left.
Do we have to memorize all of these formulas?
Yes, but I'll show you. There's a pattern, and so if you want to know the pattern, it's not hard.
What's it called? Do I even find it here today? Is that true? Time and paper.
No, tomorrow's the start test, and we will be in here. We'll be in room 115.
115.
You don't use gray paper.
There's a billion.
Yeah, I haven't seen them much yesterday.
Very nice. What's that?
All right, these are the 3 laws of cosines, but really, you just have to remember one. Because if you remember how the pattern, then the other, they're easy to see. So whatever angle it is that you have, so whatever's after the cosine, that's the same letter, but the small version that's going to be at the beginning. And then everything else is the opposite letters. So like you can see at the beginning, this is like Pythagorean theorem. So I have a squared equals b squared plus c squared. This is bc. So these two match always. So as long as you can remember that, it's pretty.
What's it called? On that bottom, is that c squared equals ba?
It's c squared equals a squared plus b squared. It's always the missing piece. So if this is c, you have to have a and b right here.
Okay.
And then the angle is the same as whatever it's the equal to part is. Okay, so law of cosines again. We use law of sines and law of cosines when we're dealing with things that are not right angles. If they're right triangles, we're going to use regular sine, cosine, and tangent because that's easier. But if we're dealing with a triangle that is not a right triangle, then we're going to use law of cosines or law of sines if we can, because it's simpler, and law of cosines if law of sines won't work. So let me give you an example of why we would use law of cosines instead of law of sines.
The law of sine equations are easy, right?
Yes.
I use this.
All right, so if we have a triangle like this, it's not a right triangle, so I know I can't use regular sine, cosine, and tangent. I can't use law of sines, because in law of sines, remember, those are the ones that have ratios. And you have to have a completed ratio. You have to have an angle and the side opposite of that angle in order to use law of sines. And in this case, I don't, and I can't get one because I only have one angle. So I don't have enough information to either get this side or get one of these two angles. That's when you have to use law of cosines. So we're going to use law of cosines to solve this triangle. It doesn't really matter since I have angle C. So since I have angle C, I'm going to solve for C first because I'm going to use this one since that's the angle that I have. So I'm using C squared equals a squared plus b squared minus 2ab. C.
I only use minutes and degrees or whatever.
I do too. It's just extra work
Yeah.
when you're plugging it in.
I can just do this angle.
Now, if I'm actually solving for C, I need to take the square root of all this, and I'm pretty sure, that this calculator can handle it all at one time. So
you have to plug stuff in pretty much in the equation?
yep. When it's like this, you can just plug it in. So
I have to get harder.
it really doesn't get a lot harder, to be honest.
Do you have to like go find stuff or something? Oh.
These are pretty easy. The only time it gets harder is when it's a bearing question and you have to draw the picture.
I'm getting stuck. I hate bearing cushions.
I don't put your foot
Okay, which one's Brian?
The bearings one.
I don't know where it is. I
This
am.
one's like two triangles,
They're
right?
all gonna sign it
Yeah.
tomorrow.
Make sure that you're in degrees. So I literally just typed the whole thing in, square root of that, all that stuff, typed it just like it was written. And I get that, which I guess I need it in degrees and minutes, so
I just want to
convert
convert it
it.
to the, you guys are blue.
All right, so it's 69.28 degrees, 6 minutes is is angle C. So then I can find angle B just by subtracting, really? Why did I just convert that? Never mind, what am I talking about? That's not degrees. That would be,
Side link.
that's a side length. Whatever. So once you have the side.
Wait, I thought that gave you angle C.
No, they gave me side C. I already have angle C.
Uh,
But now that I have a completed ratio, now you can use law of sines. So once you use law of cosines one time, then you don't have to use it again. Because now I have this, and to find my other angle measures, I can use law of cosines, or law of sines instead. So I'm going to do sine of 132, 40.
Brian, was that something really hard
Which one?
today?
Not really, no. Tomorrow's kind of is, but it's only the bearing problems.
So I'm gonna solve for angle B, and you could have solved for A first, it doesn't really matter, but I just solved B first, so that's what I'm gonna do.
Doesn't she have a question?
Oh, yeah. Go ahead, Mark.
I think you also have a
That one's like one by one.
How long does it take you up to day last first game too? For it?
I don't know how to get the cats. I don't know how to get the baseball cats.
I heard it was like super fun.
Is Jackie Robinson today, like, whatever, what other kids called it?
So I got the angle, angle B to be 17.7. Oh, I guess that's when I do have to convert. There isn't any more reason.
How did you do that convert thing when you click?
If you hit second and then angle, like where you go to get the
Yeah.
degree and stuff, arrow all the way down, it says DMS,
Okay.
and that converts back and forth.
Yeah, it's, I think it's
17 degrees, 39 minutes. And then we can get angle A by just subtracting from 180.
You just add those two and sort of one day.
So angle A is 29 degrees, 40 minutes. Okay. I can tell before I ever even draw the triangle that I can't use law of sines,
Oh,
because in order to use law of sines, you have to have a matching pair, an angle and its side, and I have an A, a B, and a C. I don't have anything that goes together. So I know I'm gonna be using law of cosines. And
How'd you know that
because,
one?
same thing,
okay.
it had a picture drawn, but, and so whichever angle you have, if you have an angle, we'll have some in just a minute that we don't have an angle, but if you have an angle, that's the place you want to start. So since I have angle A, I'm gonna start with side A, looking for side A first. So that means I'm gonna have A squared equals, and then it's B squared plus C squared, so minus 2, and it's the same two angles that you just wrote down, 12.9 and 15.4. Cosine.
Rich.
He's visiting some.
MIT.
Like me and my team?
Yeah.
And then I'm going to take the square root of both sides. And then just plug that in the calculator.
Missouri Institute of Technology.
It's true teach.
All right, this gives me side A. These are the easy ones. All you have to do is just plug it straight in the calculator with the square root sign and everything. So I got 10.5 meters. And then once you have a completed ratio, which now I do, I have side A and angle A, now I can use those two and use the law of sines instead of using law of cosines. Now you can use law of cosines again, it'll work, but law of sines is easier, so. All right, so I have sine A over side A, and I'll just do B next for a second. Next.
You said remember, right? How did you beat? Oh, you did understand. You can do that all in one track.
You can do that all at one time. And that angle B is 55.8. And then I can find angle C just by adding and subtracting 180. So angle C is 1.9. All right, so far so good?
Yes, ma'am.
All right. So now let's do one that doesn't have any angles. These are a little bit more difficult only because you have to do a little bit of algebra, but it's fine.
That's right there.
Okay. So,
Oh, you know. No angles.
no angles this time. All right, so in this case, it doesn't really matter what angle you start with. So it doesn't matter which side you put on the left. So because now let's just do A because that's not the order. So I'm going to put 9.47 squared on the left side, which means the other two have to go on the right side. Okay, so now here's the important thing you have to know. Algebraically, all of this is stuck to that cosine A. So you can't do this and add it to this stuff at the beginning because it's stuck to the cosine A. But what you can do is take all of this and subtract it from the other side. So that's what we're going to do. I am going to go ahead and work it out just so that we have actual numbers. So this is 89 points. So I'm going to subtract 698.02 from the right-hand side, which means I have to subtract this number.
So the stuff before the minus sign you can subtract,
Yes.
the stuff after you can.
Yeah. Because this is all connected by multiplication, which means technically all of this is one term.
Okay.
All right, so now I have this, and I need to get A by itself. So I'm going to divide by negative 670.98.
Oh, so you can move it.
Now I can move it by division.
Okay.
And then I need to get A by itself, so I've got to get rid of cosine. So I'm going to arc cosine. And I get 24.9. Now that I have an angle and a side, I can use law of sines to find my other angles. So I'm going to do sine of 24.9 over 9.47.
It's so funny. Bring up a girl's hand. You should be done. You bring up a girl's hand. It's all red. Yeah, like it. So that shows up such a time.
On his auditors and good alarm.
What is it? She wasn't good.
Yes, you will. No, I'll share.
Did you go here? Carry over? We should find you.
Did you tell me that when we was like, we talked about the trade almost free?
Why? Because it was they tried it on someone else or someone else or something.
Yeah.
The ball was laying across the street today.
There were 6 in the car.
So angle C is 110.1.
As long as it's the Cape Annie 6 on the corner.
not solving the whole triangle, just solve for angle B. Did it yourself.
Take a minute. Just solve for angle B? That means angle, or 6 is side B, right?
Yes.
I'll see how that one gets heavy. There you go. Oh, it is good. Where's that for those? Okay, so I did it right. That's why I was
You did it right.
confused. Saw you doing that. What? You can get a negative right and subtract that. Okay.
$33?
Yes. Just like that.
Alright. Okay, last, there's one more formula. So this is,
There's one more formula.
okay, so in the law of sines unit, little section, we got a formula for area if you have two sides and the included angle. So if I had angle A and I have sides B and C, then I would use that formula. This formula you can use if you have all three sides. So this is for a side-side-side triangle.
Triangles that we were just doing.
Yeah, if you want to find area of the type of triangles that we were just doing. So it would be area equals the square root of where S is the semi-perimeter, and a semi-perimeter is just half the perimeter. So A plus B plus C. All right, so if we're going to find the area of this triangle, first we have to find the semi-perimeter, so we have to add up all the sides and divide it by 2. So,
Does this have to be a right angle?
no. It does not.
Could you just find that area like the normal way?
If you had the height,
Isn't the 331 the height? Oh,
it doesn't have a, if it had a right angle in it and told us that it was a height, then we could use that, but we, since they didn't,
oh,
we
I
don't
thought
know
that
that.
was right.
Okay, so for my semi-perimeter, I got okay, so that's 26.5. And then I have to plug it into my area formula.
Put me on the same. Watch this. She ran that 4-level watch.
It's huge number. They were good numbers.
I want to play the cross.
All right, that's it. Y'all good? Any questions?
No, it seems really
And it's pretty easy, you just plug into the formula.
Yeah.
Okay.